I would like to welcome you all to our AI and climate webinar today. Thank you for joining us. My name is Jennifer Gardner, and I run our portfolio of executive and professional programs here at the Stanford Doerr School of Sustainability. It's wonderful to see so many familiar faces, as well as those who we haven't met yet. So feel free to turn on your webcams if you would like to, or keep them off if you prefer. While this session will provide opportunities for interaction, you will not need your webcam or your microphone today. This will be a very quick, fast-paced session with two 10-minute lightning talks, Q&A with our speakers, and then our final sneak peek of our menu of programs. Certainly, AI and climate is a massive topic, and we won't be able to hit on every aspect today. We will get to hear two distinct areas of interest, and we hope the conversation sparks new ideas and interest for you. So let's get started with a quick poll. Our speakers today would like to know how you are feeling about the very, very broad topic of AI and climate today. Everyone I speak to about this topic seems to carry both excitement and concern when they think about the intersection of AI and climate or sustainability. So take a moment to share your primary feeling today about this intersection. Are you excited, curious, cautious, or perhaps skeptical? All right. So whether you're feeling, this is not surprising to me based on our topic today, but really whether you're feeling excited, curious, cautious, or skeptical, you are in the right place because today we're not just talking about AI in the abstract. We're really grounding it in science, real data, and real world implications. So there's no better person to help us do that than our first speaker, Professor Rishee Jain from here at Stanford. Rishee is an associate professor of civil and environmental engineering at Stanford and the director of the Urban Informatics Lab. His research sits at the intersection of civil engineering, data science, and social science, developing data-driven socio-technical solutions for sustainability in the urban built environment. He has focused on modeling how people interact with buildings and energy systems across cities using micro experiments, benchmarking, and machine learning to improve urban energy efficiency. While Rishee is presenting, please post your questions in the chat to me or Riley Stevens, and we will return to them in the Q&A portion of our session. Rishee, thank you for being here. I'll hand it over to you.
Thank you, Jen. All right, let's get this started. Okay, and Jen, I'll just confirm that everything looks okay. All right. So my name is Rishee. Thank you for the introduction. So today I want to share with you a little bit of some of the work that I'm doing that's harnessing AI to understand the interactions between people, buildings, and energy systems. So I like to start with this. This is actually Stanford's campus. Last year, I was able to capture this beautiful rainbow. And it really reminds me of, in the current, I would say, discussion on sustainability, there's a lot of focus on the negative aspects and the bottom line. How do we reduce our emissions? How do we reduce our costs? What are we doing? And it really got me thinking that, there's a need to reframe this. And often, well, what I do in my research is reframe it. And I really try to think about how do we maximize building and energy systems' positive impact on human well-being. And I'll tell you how we're thinking about that. For every piece of or every concrete block or cinder block we put together, or every kilowatt hour we expend, are we making a positive impact on human well-being? And so I just wanted to start with that. I think we could all use a dose of optimism these days. And so I think this is something that's achievable. For everything we expend, we want to maximize that well-being. And so that's the framework in which I work under. And so, as I said, is what we do is we analyze data to understand interactions between people, buildings, and energy systems in cities. And my work focuses on three different scales. The first is intra-building dynamics. What happens within a building? And I'll give some examples that I think many of you will be able to relate to on challenges of our spaces, community dynamics, and finally up to the urban scale. So I won't have time to do all of these, but I will talk a little bit about the smallest scale and the largest scale. So let's start with intra-building dynamics. So for better or worse, our offices have changed. If you have pop culture reference here of Office Space, one of my favorite movies, but traditionally, this is what Office Space used to look like 20 years ago. There was a subordinate, a manager, and not so much anymore. For better or worse, this is what the modern office looks like. It presents both opportunities and challenges. And COVID did teach us a lot also. It taught us that, interaction with others is actually really important. And results demonstrated that collaboration really is effective when you're in the same spot. And so as we move to hybrid workplaces, what does that actually mean? Remote work is really good for doing work that you already know what you want to do, but brainstorming and new ideas really come from those interactions. But even before COVID, our offices had problems. I know this is a funny picture, but I think we've always been in an office space where we felt too cold, too hot, and it never seems to be right. So much of my work tries to understand these dynamics between people and the building systems that actually interact with us. Those are lighting systems and heating and cooling systems. What we try to do is think about how we optimize occupants and the people across space, time, and the teams they work for, and building systems across space and time. And we want to see how we can blend those two things together. So a little bit of what we did was develop some privacy aware inference to understand where people are in an office space. In this image, as I move through the day, you can see that red means people are there actively working. Yellow means they're in a middle state, and we'll call that to define that a little later. And then red means they've left, the space. What we can see is that at 5:45 p.m., certain spots are completely empty and other spots are highly occupied, but we have to air condition and light this whole space. So maybe there's some possible realignment we could do. And we did that. We said, okay, let's think about how we can optimize this for application of lighting systems. We saved 5% energy across 150 people. Well, I was reminded by a colleague who works for a large technology company down in near us in Palo Alto, and they said, "That's interesting, Rishee. 5%, great, nice to have." But the way we think about things, and we're talking about sustainability, it also impacts our people. When we think about energy, we can call it $1. When we call it about space, we say $10, and we think about people, it's $100. So if we're going to expend energy and it's impacting our workforce to do better things, that's for where we're trying to go with this. So it made us rethink. And we started thinking about beyond energy. What are opportunities for social interaction? We worked with colleagues in the business school to understand how collaboration actually works. And we can start to think about when there's these opportunities for people to interact with each other and given different things. And we can look at when this will occur. This data is pre-COVID, but you can start to understand this becomes even more important when people are in the office 3 days a week. How do you design a space to actually facilitate that? And so our future vision in this is how we design energy efficient and collaborative spaces. How do we find that sweet spot between these two design elements to really drive forward our goals of sustainability? And that means for every kilowatt hour or dollar we spend, how do we maximize our human outcomes? So now, and I guess another sort of cutting edge piece on this element is we're starting to develop a Gen AI model to modeling operations of facilities. So a big challenge that occurs is, building operators are often inundated with requests. I'm too hot, I'm too cold, or this fan is malfunctioning. And so it's really, really hard to understand and make decisions. This is where we think we can fine tune a ChatGPT like Gen AI model, but really start try to teach it building physics and other first principles. This will help a building manager to augment their decision making. And be clear here that we don't see this removing the user just yet or the operator, but augmenting them, especially if they're managing multiple facilities and being able to manage them effectively at the scale of the individual occupant. So now I'm going to shift all the way onto the other side with the 5 minutes or 4 minutes I here have remaining to talk about the urban scale. What happens when we zoom back out? So I think if for those of you who are from the Bay Area, I actually live in San Francisco. This is the Salesforce Tower when it was built. That's number A here. Thinking about building A meant we also had to think about B, C, D, and E. Salesforce Tower wasn't being built in the middle of a field. And the challenges of that is that there's mutual heat transfer, there's shading effects, and there's even aspects of urban heat island. So how do we actually do this? The current state of practice means we just model building A as if it's in a large field, but we know most of our buildings are actually being built in brownfields or real cities. So we developed a suite of models that incorporate AI for three different stakeholders. One is the designer and owner that would ask, what is the energy impact of design changes and retrofits given this urban context? Not just on my own, but adjacent buildings. The other one would be a policymaker who wants to ask, which buildings do we want to target for what type of retrofit? I see all these buildings in this picture. I only have incentives to give out for 5,000 of them. How do I do that? And then finally, a planner or developer who wants to think of a large scale project of what impact do buildings and other urban systems, tree, roads have on energy usage. And each of these blends AI tools with building physics, first principles. And I think that's where really the opportunity is how you combine these two together. So an example of how we do that for a designer and owner is like this. We create a baseline energy simulation. This is the fundamental building physics. We combine it with the machine learning or now some new AI models, and that helps us inform our retrofit strategy. So the cool thing here is that when we ran this in downtown Sacramento, we found some very cool results. So the first thing we found was that to reach our 80% energy savings goal, we could retrofit half the number of building by taking advantage of the urban context. And then we looked at specifically window and lighting retrofits, the same thing held. So what we're also seeing is that we're missing the positive impacts of the urban context, especially when we're talking about heating and cooling. So the final thought here is that, when we integrate AI and physics for urban scale at a building energy model, it really helps us define and drive forward our retrofit targets. We can reduce them by almost 50%, and it opens pathways for large scale system synergies. How we integrate our buildings with renewable energy, autonomous electric vehicles, and all sorts of things. And the thing that I've been really thinking about is how we integrate this with our challenges of affordable housing. We have affordable housing, land use, and energy sustainability challenges. These are all intertwined. You can't disconnect them, and AI can serve as a critical tool to help us answer these questions. And with that, if you have want to learn more, you can visit my lab's website, uil.stanford.edu. And I think we're going to be doing questions after David's talk. So I'll pass it back over to Jen.
Excellent. Thank you so much, Rishi. This is really fascinating research. We really appreciate you bringing all of this to our attention. For those of you with questions for Rishi, please post them into the chat, either to myself or to Riley Stevens, and we will pull those questions out for both speakers after the next presentation when we open for discussion. So moving into our next lightning talk, I am pleased to introduce David Farnham, who is the VP of AI and Engineering at Climate AI, where he leads all technology development. He brings over 15 years of experience at the intersection of physical sciences, machine learning, AI, and tech development. David holds a PhD from Columbia University and has served as a research fellow at the Carnegie Institution for Science, as well as Stanford University. His work has been published in more than a dozen peer-reviewed journals and featured in outlets such as Wired and The Independent. Dave, thank you for being here. The floor is yours.
Thanks, Jen. And I can't help myself but say I was really thrilled when I saw Rishee was going to be presenting as well. Maybe over 15 years ago when I was visiting Columbia, actually deciding whether to go there, Rishee was one of my tour guides. So awesome to see where the work has come.
Now that you name it, David, I remember that so clearly. Well, I'm glad I sold you on that at the time.
You did. You did. Awesome. All right. Enough with the personal anecdotes there. Let me pull up my slides here. And as Rishi did, I'll just ask someone to yell at me if they are not pulling up. Let's see, loading. I think we're good here. Awesome. Thank you for the thumbs up. So yeah, keep this brief. I'm going to talk a little bit about what we do at Climate AI, and then a little bit about some of the opportunities that some of the recent breakthroughs in AI development have sort of unlocked for us in the market at large, some of the challenges that come with that, and then a few sort of case studies about how we service customers. So just a little bit about Climate AI. We're primarily servicing food and beverage and agricultural customers who are, not surprisingly, very vulnerable to weather and climate swings and climate changes. We forecast the weather and climate. So, just like a standard weather forecast or a seasonal forecast out 6 months, we also do long-term climate projections. But really critical to a lot of our customers are what we call impact models. So actually translating those weather forecasts into specific measures that actually drive decisions for businesses. And I'll get into a couple of examples of that. And then using primarily agentic workflows to allow our customers to have flexibility to access the information that we're providing for them. And I'll get into a few examples of that. Really quickly, again, sort of overview of what we offer. So when folks think about climate tech, there's often this distinction between mitigation companies, thinking about carbon markets and that sort of thing, and then adaptation. So we're solidly in the adaptation space. So the idea being that we want to help folks to basically be more resilient in the face of weather and climate swings and changes. And we do this via primarily through two products which are sort of separated by time scale. So there's Monitor, which is really that weather and upcoming seasonal forecast. So some of the use cases there are customers who want to understand how how is the barley looking in Saskatchewan, or the coffee in Brazil, or the cocoa in Cote d'Ivoire, the major growing regions of the world. How has weather progressed so far during the growing season? What is it forecasted to do? And what does that mean for global supply and global supply shocks? So that's sort of what we refer to as our sourcing persona. Production are our customers that are actually doing the growing themselves, and they want to understand, hey, is there an upcoming drought or heat wave, and what are some of the mitigating actions that we can take in terms of mitigating the effects of those. And then sales and marketing to understand, hey, maybe the rains are there's a strong forecast that the rains will come early to a region, and so farmers will want to procure seeds 2 weeks earlier than normal. And so if you're the company providing the seeds, you want to be able to have those available for the farmers to buy. And then on the adapt side of things, which this is longer term climate projections decades into the future, most of our customers are using it more in, for example, the R&D space. So thinking about what types of seeds might we need more of as extreme heat, or extreme heat during a flowering season for a critical crop becomes more frequent, maybe obviously heat resistant. There's different types of that. And then understanding where might some of the main growing regions start to migrate as we see more changes. Then on the finance risk side of things, understanding a big one here is water risk. So especially in the agricultural sector, understanding, if a farm is relying on groundwater, what's that going to look like in 10, 15, 20, 25 years from now? And are there sort of other regional sources that they could augment that with? And then sustainability, which is primarily the sort of reporting functions here. You see TCFD and CSRD. In some cases, those can we always try to move beyond what we refer to as sort of like a box checking exercise to actually try to provide some actionable insights. But of course, there's reporting regulations there that we support as well. So I will just move into some of the opportunities specific to our work, specific to some of the more recent breakthroughs in terms of AI. Specifically, I'm thinking here about large language models and how ubiquitous they've become, and agentic workflow frameworks that have become quite accessible to a large number of companies. And think about what it unlocks for our customers is sort of four things. And these are actually quotes from some of our customers that are really trying to drive actions with the data we're providing. So interpretability is really about allowing our customers to do things like input their delivery schedule for maybe they're, growing peas and producing peas, and they see that there's an upcoming risk of torrential downpours that will have severe impacts on their production. But they always have to do this mental calculation, or they have a series of spreadsheets to understand which sort of production delivery will that actually impact. And so wanting to actually automate all of that, because it actually is automatable. Flexibility to create things like custom dashboards, because one of the lessons I've learned is, as much as we want to sort of understand the market through finite set of personas and folks who have a certain workflow with which they make decisions. Um, Most sectors can be quite idiosyncratic in terms of how each customer, how each company actually makes their decisions. So having some flexibility to be able to feed in our insights is really important. And it's really hard to find the dashboard that meets all those needs when you're thinking about really sort of nuanced and in some cases esoteric calculations where you have not only the climate component, but then you have decision making under uncertainty, and depending on whether you go left or right and what the probability of the weather outcomes are, it can become fairly complicated. Communication is another layer that I actually sort of think doesn't get talked about as much in terms of, we can have one of our climate scientists, join calls with customers and explain, here's exactly what this report means, here's how to interpret the probabilistic nature of it, et cetera. But a lot of LLMs, if you give it the correct information for them to understand what is the context for this specific customer, can do a really good job of actually having sort of dynamic conversation and explaining to folks the ins and outs of things in a rigorous and also consistent manner. And then the sort of crown jewel for us is actionability. So I mentioned we don't really want to just stay in the checking the box side of things, but really want our information to be able to have some leverage or some impact over decisions folks make. In a lot of cases, that actually just means being more confident in the decision you're going to make, to understand that yes, indeed, the science backs this up. And I'll just highlight one thing here that's become really interesting to a lot of our customers is this sort of standardization and automation of suggested actions. So we have a lot of customers who are advisors to large number of growers. And, there's a finite number of climate and weather shocks that can happen on a farm. And there's a finite number of actions you can take to mitigate against them. But to have a sort of flexible system that delivers, hey, this, heat wave is upcoming. Here are the 9 things you should consider doing, and be able to, send that out via text message to all your growers. That just sort of ensures that there's no options that are not being thought about in that instance for whatever reason. So that's sort of that automation and making sure you're not missing any possible actions you could take. Really quickly, couple of other opportunities in the climate and weather space with AI. So we're software as a service. We're a software platform. I have definitely seen that the speed of our ability to roll out features and even a new platform with AI-based co-piloting has gone up a lot. There's certainly some cautionary tales there in terms of for example, we use it a lot more on the front end than the back end because, just to clarify, the science is still the science. I don't want LLMs to be doing science for us. But in terms of spinning up a new dashboard to test out with customers, that has really been quite a game changer in terms of how easily we can do that. On the more sort of scientific side of things, one of the things about machine learning and artificial intelligence models for weather forecasting in particular is their inference is really fast, which basically means it takes a long time and a fair amount of power to train the models. But once you're trying to make a real-time prediction, it's very quick. So this can be very useful in a situation where you're trying to understand what are the sort of bounds of uncertainty of where a tropical cyclone might head. And with traditional numerical forecasting, it takes a long time to basically complete those runs. And with an AI model, you've sort of put all of that time in the training phase. But when it comes to real-time applications, you can get much better quantification of uncertainty, which in a situation like tropical cyclones, where it can be devastating if it's going to hit you, is really important. Couple of challenges that I've been increasingly seeing, not surprisingly here, customers are concerned about security. They should be for a couple of, I would say, sort of two main buckets which are related. One is they want to understand that, we're a business to business platform and they don't want their information getting leaked to our other customers, obviously, some of which may be their competitors, right? So we have to be really clear about that that's not happening. And possibly an even bigger potential issue is their proprietary information actually getting leaked out via prompting LLMs, for example. I have a friend who works for a National Football League team, and their role would some of the tasks they do would be amazingly assisted using LLMs, but the team is like, we won't allow that anywhere near our systems. And I understand why. I mean, there it's proprietary leaking proprietary information risk. Change can be scary. I put this here. I don't know whether that's the right title, but the other thing that we come up against quite a lot, and I totally understand this, is when you're showing folks, hey, we can make your decision making more efficient, can sort of highlight the risks and opportunities more consistently. It can still be scary to say, hey, I'm going to alter the way I'm making my decisions, because if something goes wrong, it's easy to say, hey, it was that AI. Why did you ever sign up for that? Even if you can show, hey, well, we would have made that decision anyway, or it would have been worse. It's something that is very real. I think potentially, particularly in the agricultural sector, it's something that there's excitement, there's a lot of caution, there's a lot of skepticism, um, similar to the poll, Jen, that you put up. Although I would say maybe even it almost, in my observation, it's almost a little more bifurcated, in that some people are super, super pumped up about it, and some people are super like, oh, I don't want to go near that. And then the last one here, this of course is not all of the challenges, but this is a real one, is just the power needs, right? I mean, we hear about more and more parameters in these LLMs, and I think it's somewhere around 1 to 2% of power consumption is going to AI these days. But there are projections of that really blowing up. So want to acknowledge that really quickly, because I know I've taken a while here. But just to give a couple of examples of work we've done. This was work with the World Bank, actually, and looking at um, economic impacts from potential power outages from extreme heat events that overburden a power system. And here, actually, the use of AI is not actually in the science of it, but what you come out with is you come out with these projections for, all cities globally, just a huge amount of data. And, if you're a computer programmer or scientist, and you really sort of know what you're doing, you can start to query that data and look at, what are the trends across different cities, et cetera. But with something like an LLM and RAG, in natural language, you can sort of query this database that we've produced scientifically, and sort of ask questions about sort of what's going on in this region, that region, relationships between the heating versus the cooling side of things, et cetera. So that's speaking to that sort of communication layer. That's one area that I really like, that I think can sort of scale some science communication in a way, using natural language. And then last one is just an example of one of our customers. Several of our customers use our data for understanding supply chain disruptions, Hitachi being one of them. And here, machine learning comes into play more in our forecast. So our tropical cyclone forecast, we do a seasonal forecast for all basins of the globe, and Hitachi's supply chains are global. And so they use our data to understand what is the risk of disruptions to supply chains ahead of time. And apologies for going a minute over, but I'll turn it back over to you, Jen, and thanks for all of your attention.
No, this is great, Dave. And this morning's session, we talked a lot about these power needs and these demands and predictions in that area. So it's very, very relevant. These are super powerful insights from your platform as well. So everyone, we're now going to shift into our Q&A portion. We'd love to bring your voices into the conversation. So if you haven't already, please drop your questions into the chat to either myself or Riley Stevens, and I will direct them to one or both of our speakers, depending on the topic. So let's jump in. Dave, since you were just chatting, I wanted to bring this question to you first because it's about your platform and your data. So we have someone asking, can your service predict potential shortage of water? You started to talk about water because governments can really use this information for resource management, they're saying.
Yeah, so one of our modules, shall we call it, is all about water risk, so surface and groundwater risk. So I guess the short answer is yes. Obviously, some every region talk about sort of idiosyncrasies, every region in terms of their water risk, and then if you even get into water law, becomes can become a can of worms. But yeah, the answer is yes, and we use that. That is primarily used by folks trying to understand, as I mentioned, the water risk for agricultural entities, especially it can be banks understanding, hey, is this, is it going to be practical to farm here for the next 15 years? Or those years when water is limited, are they going to become more frequent? And are there regional sort of mechanisms by which they could procure water for irrigation, or is it difficult? So that's a long-winded way of saying yes, Jen.
Yeah, no, that's great. Another question specifically on your platform and your data, and then I have some questions for Rishi as well. So we have someone asking, so I'm going to read this directly. Given that climate change is creating weather patterns outside of historical baselines, how does climate AI address model reliability when training data may no longer represent future conditions?
It's a great question and a great point. And I didn't go into this explicitly, but for our long-term climate projections, we are still relying on physics-based models. And then we have a layer of machine learning on top of that. But what I wouldn't want to do, most folks who've played around with an LLM, and they've gotten better, of course, but are familiar with hallucinations, right? So we don't want to have a hallucination happening with our projection for 2080. So we still rely on physics-based models that are an extrapolation of our best understanding of the Earth and atmosphere, and oceanic systems. And then what we're doing is we're basically correcting those models using machine learning and statistics. So yeah, and I saw a question directly to me, and I'm sorry, I'll just sneak this in. Somebody asked just Eastern European cities for the World Bank, and just to say that was what the funding was for, but we actually did it globally. That was the name of the white paper, though. So.
Perfect. And so for both of you, we have some questions also about data gaps. So where do you see current data gaps in all of your work, and how do you see that maybe progressing? And Rishi, we'll start with you.
Sure. So that's a great question. I think, a big challenge we see is that we have a lot of data from remote sensing, from these type of things, but what we like to call in situ data, data actually sensed at the individual building level or that is really hard to get in some parts of the world. So there's challenges in what we like to say we have data rich environments and data scarce environments. So in data scarce environments, that's when really having those first principles, that those physics-based models really helps to fill the gaps. We can simulate. And as we get more and more information, if we start to understand what is the material that walls are built out of, we can embed that into the models to get smarter and smarter over time. And so what I would say is that yes, there are big data gaps, but what I think these AI plus physics-based models, which both David and I work with, allow us to sequence that data acquisition. And it also allows us to take a step back and say, okay, if we have a set budget and we need to get certain types of data, where should we spend that? Where do we think we're going to get the bang for our buck in terms of data acquisition? It's sometimes more expensive than we would like. And also there's big privacy concerns if you're talking about that at the individual level.
Yeah, I guess I would apply what Rishi was saying a little bit at the sort of environmental global scale, but I'm personally always hungry for more data. I mean, in our context, precipitation data is a big one, right? I mean, that's really big for any farmer. And to Rishi's point, we have a lot of global data sets. But when it's a satellite retrieval and you're working in an area without a lot of rain gauges, uncertainty is large and in some cases unknown. And it's really important for folks to have, forecasts and even just observed data that is well calibrated. So I, I hate to sound overly simplistic, but I would say, yeah, that in situ data, but just a lot more of it. And just to like sort of be explicit about it, the more complicated, complex an algorithm becomes, the more data you need to really sort of be able to train on. And I think a lot of folks look at things like climate data and say, well, this is massive, right? Because you have, different grids globally, et cetera. But a lot of the adjacent grids are actually related to one another, so they're not independent data points, et cetera. So all of it, I guess. And the last thing I'll say in terms of gaps, and we've seen this with customers, is customers are really excited to use, agents, for example. But in terms of those agentic frameworks being helpful to an individual customer, it needs to have context on their data and how they or on their operation, how they make decisions now, what other sort of context should be factored in. And so then having well organized data internally actually unlocks the value there. And most folks have data, but then when you really sort of get into it, it's like, okay, what's the quality? How has it been maintained, et cetera? And that's where, some more success comes with some of the bigger companies that just have the resourcing to have been able to set up those practices of having all that context that can actually guide an AI in the right direction to sort of be salient for that customer.
Yeah, that's great. So Rishi, you talked a lot about equity, which I think is a super fascinating point here. And we have a couple of questions that I'm going to do my best to combine
Of course.
here, where people are asking about, what should we expect in the next 5 to 10 years in terms of other research integrating physics and AI, especially with like lower resourced devices and sensors, as well as kind of the integration of HVAC cooling heating systems instead of traditional air conditioning and all of these kind of classic building um, aspects into more newer technologies.
Oh, great. So let me try because I think there's a multiple part
Yes,
question there, Jen.
exactly.
So I think the first piece is that what these models have really done is enable low cost sensing to be, I would say, easier to use. And so some of these sensors, I'm always reminded, this is not my space, but I have many colleagues who work with air quality monitors. So Purple Air, if those are familiar with it, developed a low cost, air quality monitor for a tenth or a 1/20th of the cost of an EPA rated one. It allows me to put one on my wall, and they use a lot of clever machine learning techniques to correct it. It's not perfect, but it gets us a lot of there. I see that occurring in many different dimensions, especially in the buildings and energy space. Can we use cheaper sensors and get away with understanding things and characterizing them with new data-driven models? So that's on the first piece. The second piece, I think, is on new technologies and equity and these challenges. So I think a big challenge, and David alluded to this, is heat is going to be a big challenge worldwide. And I think one thing that these new models and methods can help us do is help right size the solutions to different places and help maybe correct challenging behavior or harness that behavior. And the example I give is that, there's challenges regarding sort of, for example, everybody's trying to adopt heat pumps in California. And those are really wonderful when they replace our natural gas furnaces. But a secondary impact that's happened is now, for the first time, especially in the San Francisco Bay Area, we have cooling. So now we're adding cooling load onto the grid. And so it really helps us think about, okay, how do we work? Can we model these systems? I'm doing a project on natural ventilation and natural cooling, in which can we, develop new models and methods that would help assist people know when they should just open their windows, because yes, their system may be kicking on, but they could override it and it's actually a gorgeous day. And so how do you nudge people in that and develop scalable models for that? That's where AI can help. Right now, you have to do a complex CFD model. No one will ever do it. I'll just be honest, except for the most highest end buildings. This makes those things accessible. So I think a lot of what I see AI doing in the building and energy sector is making a lot of tools accessible, down from all these complex models that you have to hire an engineering firm for. I see 5 to 10 years down the line, something that you can, open up an app and it would be able to help you make these decisions and get you 80% of the way there than what we did before.
Awesome. Thank you. And for Dave, how how much is your software being integrated into actual farm and agriculture equipment versus being used as dashboards by decision makers? Can you help us understand that?
Yeah, almost all of the latter. It's almost all dashboards and or like alerting functionality. So there could be one sort of administrator for a customer, and then they can just send out reports to folks who need that, who maybe aren't signing into the dashboard every day or an SMS message. But yeah, it's that second component. The integration mode for us is companies who use our API. Like I highlighted Hitachi, right, who has their own internal models for estimating whether there's a potential disruption that's going to happen, and they're ingesting our data via that. But yes, different from something like precision agriculture, where you're constantly retrieving data from sensors on tractors or soil moisture probes and that kind of thing.
Yeah, awesome. Thank you. So both of you were really actually talking a lot about how AI can help people in their decision making. It's not doing the work for us. It's not necessarily taking our jobs. We are leveraging it as an additional tool, right? And so how do you see the role of AI in decision making in your fields changing in the near future? I always start with Rishi.
So for me, it really boils down to, maybe one day this will not be the case, but I think for the foreseeable future, AI is really going to have to augment decision making. And there's a couple of different pieces why I think that's the case. The first is it's really not that smart and hallucinates. And when we're talking about the decisions that we have to make, they're big decisions. So you build something, you build a building, you change, you rip out walls. Those are hard to say, sorry, Command Z or Control Z, undo. They're not easy to do. We're talking about real pieces of infrastructure, laying rail lines and these sort of things. So that's where I think there's just going to have to be that level of scrutiny. I think the second piece is actually on, and David spoke a little bit about this, is the comfort of decision making. And, the flip side of that is liability. But do people, are they comfortable with relying on a black box model that they don't have any intuition around? It's really hard to get on board with that. And so I think it's going to be a tool that maybe opens up different solutions or possibilities that are still going to have to be made, decisions are going to have to be made by on the human level. And then I would say the last piece to me is really about the fact that it's going to augment decision making much more because it there's almost a political dynamic of this, in the sense that what I mean by that is that we often are trying to make some of these decisions on large scale things based on consensus. And so what the challenge that AI won't do is it often feeds through one specific thing. And this is a big challenge when we're talking about things like energy equity and these sort of challenges, because it can often reinforce what is the common knowledge being discussed. And so that's the negative aspect. If you type in, some common things into LLMs, it's going to feed you kind of what you want to hear and the same dialogue, when often what we need to be doing is taking a step back and looking at the whole solution space.
Well said. I would sign on. I would sign on to what Rishi said. The only thing I'll add or just sort of emphasize is, yeah, I see it as another tool, in many contexts, a really powerful tool, and a tool that you can work with in real time without having, gone and studied how to program it for, years and years. So I think that opens up a lot of cool possibilities. But I don't see, in the context that I work, humans being out of the loop. I think there's too many anytime soon. There's too many challenges with it. I also think, we as humans, when you really look at like how long it takes for technology to be adopted and to really get into workflows, it always takes longer than we think. Maybe I'll be wrong and I'll be eating these words in a couple of years. But I do think, yeah, I think it's going to continue to be integrated into decision-making processes, but I don't see it as an automated decider for all the reasons Rishi laid out, and probably more. So yeah, and also in terms of like I mentioned, we're not certainly not LLMs, not really like AI is not doing science for us. I don't want that to happen anytime soon. I do think it offers a way to scale and to apply really great science with a sort of more seamlessly. But yeah, so
Excellent.
plus one to
So I want
Rishi.
to Perfect. So I want to let you each have some closing words, but if I may just add to that, we have some government officials and board directors of corporate multinational companies here, and I'm curious what either advice or kind of takeaways you would have specifically for these high-level decision makers. And Dave, we'll start with you this time.
Yeah, that is a great question. I guess for my takeaway, I'll just sort of repeat the last thing I said that in the context of science, both Rishi and I are scientists. It's not replacing science. I know there's some sort of like AI research, pure AI researcher tools that like I'm interested to play around with it, but I don't think it's replacing that anytime soon. Um, I think uh, I think in terms of any insights for the decision makers that you listed there, it's you know, take it seriously, have your team sort of understand what the capabilities are and are not. I know as we were building out our agent capabilities, like we just took time to understand where we felt like we needed to apply more guardrails, where I mean that was a lot of it. What they could do, what they couldn't do. Also, the earth is, somewhat changing, as you develop, right? Because development speed is really quick these days. But I guess the main thing would be not to avoid the a judgment of this is the greatest thing ever or this will never be anything, and to sort of be open because I think it's constantly evolving. And that's what I'm seeing as we're applying it.
Thank you, Dave.
Awesome. I would agree with a lot what Dave was also talking about. I think one thing that really strikes me, if I were to take a step back and say, is that, I think AI tools, or I would tell all of you decision makers, use AI tools to speed up your process. And so that would allow you to explore more scenarios. That's the way I would sort of generalize that. And anything you're doing. I think before you had a set of 5 scenarios because it took a lot of work to get the background research on it and to analyze and to understand. If you can expand that to 10, you're opening up your solution space a little bit larger. But still, that end decision really needs to be done by you and your colleagues.
Wonderful. Excellent. Well, thank you all for your very thoughtful questions. I'm sorry we could not cover every question. You all submitted fantastic questions. And of course, a huge thanks again to Rishi and Dave for such a rich discussion. We're going to wrap the Q&A section here, but the conversation is not over. For those of you who'd like to stay on, we're now shifting into a sneak peek of Stanford's upcoming executive programs related to sustainability, leadership, and emerging technologies, including how you and your organization can get involved. If you are working on budgets in particular right now for 2026, you may want to make sure to include one of these programs in your training and professional development budget. So let's start with our flagship program. This is called the Stanford Leadership Experience, Science, Innovation, and Resilience in collaboration with the World Business Council for Sustainable Development. So this is a 5-day program here on campus designed for senior executives and board directors who want to be at the forefront of responsible business and innovation. So across the week, participants will engage with Stanford faculty from across the university, including the School of Medicine, Law, Business, and Engineering, We have industry experts and, of course, many of your peers to discuss topics like systems thinking, organizational resilience, emerging technologies, and the evolving demands of sustainable strategy. My favorite part of this program, everyone, is the excursions where you will get out of the classroom and explore some of Northern California's unique sustainability challenges and solutions firsthand. This is really a great fit if you're looking for a transformational, immersive experience that strengthens both your leadership capabilities and your understanding of the forces shaping the future. Next, we offer a series of Stanford masterclasses, each focusing on a high impact topic area. Two of our upcoming masterclasses which will take place at the beginning and conclusion of San Francisco Climate Week in April, include the AI and Climate Masterclass. So if you enjoyed today's session, this will be a full day on campus program diving much deeper into the intersection of artificial intelligence and climate action. So really what's possible today, what's emerging, and how leaders can navigate both opportunity and risk. We also have a climate innovation masterclass. This is a shorter partial day experience hosted here at Stanford. And so this session dives into the innovation landscape, breakthrough technologies, entrepreneurial ecosystems, and the levers one can use to accelerate climate positive solutions. Master classes are open to learners at all levels and are ideal for people looking for a deep dive learning experience in a short time frame, or maybe you're wanting to sample a Stanford perspective before committing to a longer program. And then for a deeper, more flexible learning journey, we offer the Energy Innovation and Emerging Technologies program. This is a 100% online and on-demand offering designed for working professionals across all levels. You can choose any 5 courses from a curated set, and this really allows you to build your own pathway across energy systems, new technologies, sustainability fundamentals, and really just this ever-changing landscape. So if you want something self-paced, technical, and customizable, this is a great option. While we have additional offerings that you can learn more about on our website, we wanted to mention 2 final programs today. One is the Strategic Sustainability Leader Program. This runs May through July 2026 in a hybrid format. So there's both online and on-campus components. This program is designed for leaders with sustainability strategy at the core of their job description. So it helps you build the capabilities, influence, and cross-functional understanding required to move from sustainability awareness to sustainability leadership. So if you are responsible for shaping corporate sustainability efforts, or you want to elevate your influence in this space, this program may be the best fit. Lastly, we want you to be aware that we partner directly with organizations through what we call custom programs. So these can be delivered here at Stanford, on site at your company location, online, or in a hybrid format. And it's really tailored to your company's needs. So we support a variety of activities, including board trainings, executive retreats, or we could collaborate with you to design an entire company-wide learning journey. So this is really a powerful option for organizations looking to build shared language, accelerate culture change, or to scale sustainability and innovation learning across teams. So we're here to help you choose the right pathway. Feel free to reach out to our team if you'd like guidance based on your goals and your organization's needs. Before we close, just a quick reminder that that you will receive the recording link of both sessions from today, along with a few additional resources and program details, as well as how to contact us directly. This will come to your inbox within the next 24 hours. So on behalf of Stanford and our team, thank you for spending part of your day with us. We look forward to welcoming you to Stanford in 2026. Take care.